So what I promise you guys is by the end of this session, one, you'll not be intimidated by the words your techies throw at you, right? API bana raha hu, right? Bootstrap, all of that, right? So point number one, you'd not be intimidated with the jargon thrown at you. Point number two, you'd have a sense of the tech project management. What are the different pieces that if you have an idea, you have a few screens involved, you'll be able to estimate how much effort goes into execution of that project, right? So a lot of times, you say, okay, it's an easy thing, can be done. But the point is, as a non-tech founder, you're looking at the output. The output may look simple, but then the amount of effort which goes into execution of that output may be not trivial. It might take a lot of effort to execute that output. So point number two, as I'm mentioning, is you'd get a sense of what all goes into execution of whatever idea you might have, right, by the end of this session. And point number three, of course, is once you have an idea of what it takes and once you're not intimidated by jargon, you'll be able to get things done out of any skilled person. So, I mean, a lot of times when we say that a startup needs a CTO or a tech founder or a tech leader, I think a large part of the tech leader's work is in terms of task division, is in terms of how you put things in one place, right? So, I mean, of course, security and all these considerations do come in, but at least at the MVP stage, where you're building the initial part of the tech, perhaps that's not a pressing issue, right? When you're bringing out a prototype, if you're able to understand the pieces involved, you're able to break things down and then assign things to people and get it reassembled. I think you don't need a CTO or a tech co-founder. You can run the tech yourself along with a few interns at an MVP stage. And once your company has traction, I'm pretty sure you can hire a good tech leader who would bring in the security and the scalability and all the other aspects which come in once you're at a later stage. But at the initial stage, I think even if you have a CTO, the CTO wouldn't bother too much about all these things and just try to produce clean code, make it work, and then figure out how you can make it scalable. Because as long as you have clean code, right, as long as your logic is good, eventually it's just about infrastructural upgradation so that your application scales to more people. Of course, there are some optimizations which come in, but I mean, even if you hired a CTO, ideal thought process, don't worry about the optimization upfront. Make it work, test it with some users, figure out if this is exactly what you would like to build. And if you're sure that this is exactly what you'd like to build, at that stage, you'd go ahead and optimize it. But in the initial stages, anyway, you don't worry too much about optimization. So yeah, these are the three expectations that you're able to you'd understand what your project entails. You're not scared by jargon. And the third part is you're able to run the show along with your interns. Is hopefully what I wish to achieve at the end of this 40-minute session. So, and one question is a lot of people and I request all of you to please keep your videos on. The ones who just came in, I request you to keep your videos on.
Don't worry. McDonald's.
Which mic was it? I request all of you to please keep your videos on. It's a little difficult to do a session when my participants' videos are not off. I request you to please keep your videos on. Yeah, I request all of you to please keep your videos on.
Somehow the video has gone off. I do not know, on its own.
Yeah, you can just, I think if you're on the mobile and if you tap between different screens, Zoom automatically switches off your video. Okay, great. So now let's move into the, one more disclaimer which I want to send out before starting the session is if somebody, tells me get to the point, you can just go through YouTube, this entire recording and watch the last 15 minutes where I'll be getting to the point. But then you'll get nothing. So I'll be starting in a Socratic format with something fundamental. Okay. But if you want me to get to the point, you can just drop off from Zoom, watch it on YouTube, just go to the last 15 minutes and watch the last 15 minutes. I'll be racing like a rocket in the last 15 minutes. But initially it's a general warm up. Okay. So now let me start. I'd like to ask you all a question. You're all entrepreneurs and you're all building amazing businesses. So I'm sure you'll have wonderful answers for my questions. So my first question for all of you is, why do you think industrial revolution was very important? In the history of business, why do you think industrial revolution was very important?
To optimize the daily workflow of any part or any process, I can say.
Okay, thank you.
Yeah. Yeah, my answer is it brought in a lot of efficiency.
Okay.
Yeah.
So now a simple question for all of you is, you said industrial revolution brought in efficiency. So a question which I have for all of you is, why did they move everything to factories? Why are you trying to have the production in one place? Why did the operations get centralized?
For better control,
Why would you want better control?
for better observation, because earlier in the management theory, it was known that if you cannot control, then you cannot manage. And whatever you can see, you can control. Whatever you can measure, you can control. That was the reason. And if you let people alone, you may not get the full efficiency.
Okay. Any other reasons?
Maybe consistency, quality management.
Okay. Why do you think consistency and quality management come in if everything moves to a factory?
It's centralized, so everything is controlled under one hood. So everyone is in the loop, and it's easy to track as well.
Okay.
I
So,
think to maximize the maximize the production with a limited supply of resources in a short amount of time.
correct. So now if you think about it, there are some bakery chains, right? I mean, in your city, there must be some bakery chains. So now, these bakery chains have a central kitchen, right? They don't produce the bakery items in the respective stores. So what is the advantage you think the bakery gets by centralizing the production in one place with a central kitchen?
Same quality.
Okay. What if you have one really good chef?
Will reduce expense.
That
Will
one
get-
good chef controls the entire floor for the, say, 20, 30 branches in the city, right?
Yes.
And you
Maintenance
cannot-
standard.
Please go ahead.
Maintaining a standard.
Correct. And then you start creating barriers for the other bakeries who are coming into the city, right?
Yeah.
You're such a huge volume of business. So you can hire the best damn chef. So you raise the bar in terms of quality. So if some new, you become the TCS of bakeries, basically. So you're doing it at such a scale that you can afford resources at a scale that somebody else wants to come in. It's difficult. So now I think we all agree on some of the central ideas of industrial revolution, right? Where specialized expertise was moving to a factory. That's my point number one. Let's park it there. That's my point number one. Let's park it there. I'll come back to it. Now coming to point number two. In the early 2000s, right? I was only 9 years old in 2000. I'm assuming most of the people are also so. So then there was the BPO revolution, right? So now I have a simple question. Let's say you're a hospital, and you're in the US, and there is an emergency case. There's a nurse who's available, and there's no doctor who's available. The doctor who just left, poor guy, worked for 20 hours straight and just went home. So even if he comes back, there's no way he'll be effective in treating the patient, and there's no doctor available. What would you do?
So find out the similar type of cases before, because BPO documents it very well, and take the help of the.
I mean, I just use BPO as another example. Here I'm saying you're just a hospital. You have a nurse over there, and the nurse is alone. There's no
Okay.
doctor.
Okay. So that's what I'm saying. If the nurse is alone, if you have a complete process documented and
But the,
well
but the
delivered
nurse,
earlier.
the nurse usually can't execute the process. The nurse needs someone to guide her with the do's and don'ts, right? Because it's an emergency case.
So
You need a doctor.
basically there are two things in medicine field. You mean surgery or you mean medication?
So it's an emergency. You need to hold the patient until a proper doctor can come there. So what do you think you could do?
I can motivate the nurse so that she can work properly.
Who?
Me, like I am the nurse or I am with the nurse.
So I mean, you're the hospital owner. You don't have an
Okay.
MBBS. You don't have an MBBS. You have an MBA.
Okay.
And there's a nurse over there. So what do you do? That's my question.
The nurse will be having a friends, right? Or we can take a mobile. We can do a video call to some of our doctors.
In the 2000s, this was a big thing. So
Yeah.
so using the technology, they could get a doctor in India.
Yeah.
It's late night in US, but it's early morning in India. So a doctor in India might be available, and you can solve it. Or let me ask a very different question. Let us say you're a CEO of a company in the US, and you have an early morning meeting at 9 o'clock, right? And it's night 11 o'clock. You have an important meeting, so you're brainstorming. You got a very good concept, and you want a PowerPoint presentation by 9 o'clock in the morning. What do? You wake up all night, you're going to mess up your meeting in the morning. So what do?
So you assign the work to India, and then these guys have a different timing, say roughly about 12 hours time difference. So what is night for them, this is day for us, and this team will execute that job and give it back to US so that they can carry on the stuff.
Yeah. So the beautiful thing about the digital revolution is, if the work can be digitized, the work can be moved to any place in the world, wherever it can be done best, wherever it can be done at the lowest cost. And the massive growth of Indian software industry came in after this came in. Especially, Hyderabad, the city which I'm in, and some of you are also in, I think grew due to the Y2K revolution. Right? You had to change software from 2-digit format to 4-digit format of the year 2000. So I think after the BPO revolution took out, Bangalore, Hyderabad started growing very fast, because as long as work could be digitized, you could do it in Bangalore where it's cheaper. You want to answer a phone call in America, somebody's ordering for a McDonald's burger. It's more expensive to answer the call in New York, so you answer the call in Bangalore. If the work can be digitized, it can be done anywhere. After pandemic, probably it's a lot easier for us to relate with. But yeah, I'm talking of the 2000s when some of this work was done. So this is my point number 2. Let's park it. My point number 1 was you moved your work to a factory. Point number 2 is you saw the merit in digitizing things, because if you can digitize it, your work can go anywhere. Right? And if your work is digitized, and your work is digitized in zeros and ones, like right now we're trying to have a conversation. The work is digitized, but unfortunately the work is not digitized in zeros and ones. It's digital, but it's not structured. The data is not structured. Like let's say just now Hemant nodded, but I don't have the data. I'll need some image recognition algorithms maybe which can scan that video and say, okay, Hemant just nodded, or say Vajra Prasad just smiled. So I need probably some image recognition algorithms to truly digitize the data, so I can do something with the data. But this is my point number 2, that if you can digitize, a lot of virtues come in. 1, virtues as in good things come in. 1, you can do the data wherever the work can be done. You can do that work wherever it can be done cheapest, wherever it can be done the best, and so on. You can bring analysis, you can review it later. A lot of good things can come in if the thing can be digital, right? So this is my point number 2. Now I'll come to point number 3 and then move into the actual workshop. I'm just doing the warm-up. My point number 3 is now so let us say, 10 years, say 15 years back, most of the softwares would be locally installed, right? You take the software on a CD you install it in your computer and you use the software. Today, if you think about it, most softwares, they run on the cloud. You think of Figma,
Canva is there.
yeah, so Figma, Canva, many of these things. So you think of them, so they run on the cloud, right? Or even if you think of Adobe, they give you the creative cloud solution. So now a simple question. Why would you want the software to run on some server somewhere else? Why wouldn't you want it to run it on your PC?
To make the app or software like available 24/7, so that I can get business 24/7 as well.
No, I'm talking of if you are using for your personal use, why aren't you using it on your PC? Why are you running it on some server somewhere else?
Sometimes
It will be
some
helpful for
software,
the storage.
Yeah, your storage, okay. No, but these days your 1 TB hard disk and all of that, right? Storage is not a problem. Or rather, local storage is cheaper than cloud storage, right?
Yeah.
How much does a 1 TB hard disk cost these days?
it's also about the type of efficiency the machine serves.
Correct. You have a more advanced machine if you run a server somewhere else, then
It's accessible from
Whatever new
ease of access.
ease of access. Yeah, it can be accessed.
whatever new updates are there, they
Much
can
more.
be installed directly by the company and we can use it locally. So if we are installed locally, then it will be hard. Like we have to bring it again, we have to install it again. So that one thing.
Right,
is there.
installing updates, more efficient
Updates.
machine,
Yeah.
available from any device.
Yeah, yeah.
Let's say you're traveling, you want to access this application, you can access this application. So these are the benefits of doing it on the cloud, right? So this is my point number 3, that earlier we were running it in our machine, but now we realize that we can run it on some machine somewhere else and we can access it from that machine. Okay. Now, if you have some specialized expertise, as a business, would you want to do that specialized stuff in your factory, or do you want to do it in your store in front of the customer?
In the factory.
Okay, let's say, you're very good at cooking a certain kind of fish. Do you want to cook that fish right in front of the customer, or you want to cook it in your kitchen?
It depends upon the
Okay.
customer experience actually.
Okay. So in what kind of a scenario would you cook it in front of the customer?
So if the customer is interested in watching the cooking, then I will do it. And if he's a fish lover, then he will be more interested also to see that how it is done, in addition to how it tastes.
There might be cons with the fish cooking part, because fish is a little smelly, as well as for the smoke part if it's fried and all. So
Okay.
yeah, there are some cons for some cooking dish. So it depends totally on the type of cooking it is happening there.
Correct. So primarily, if you want to create customized experience for the customer, very special experience for the customer, you may want to do it in the store. Or for example, let's say you're making a custom cocktail for the customer, you may want to do it right in front of the customer. But if that's not the case, you're better off doing it in your kitchen, because that's where you have your equipment, that's where you have your team, and that's specialized for production. While your restaurant is specialized for designing the experience. So now if you think from the cloud perspective, there are 2 machines in play here, at least. So there's one machine, which is your kitchen, is your server, and there's another machine, which is your client's PC, which is your restaurant, where the actual experience is being generated, the front end and the back end. So why do you get in front end and the back end? Well, the answer comes from point 1 and point 3. Point 1, the industrial revolution, you moved everything to a factory. So you moved all your computation to a server. Why? Because you get that expertise in that server. Right? Like I asked, why did everything move to a factory? So here, for the same reason, everything moved to a server. So And also, let's say you guys have a custom algorithm. That's your business secret. You don't want that to be available in the front end PC because your competitors might, figure out how it works. It's on the front end. I inspect my browser. I understand what's going on in the browser. I can reverse engineer it. So in the back end, it's a little tougher, right? Back end is more, your data is secured and so on. So this is how we break things between the front end and the back end. But if you want to understand why front end, back end, I think it goes back to industrial revolution. So you have a factory where your specialized expertise is, and you have your storeroom or your restaurant where you're creating the experience for the customer. So typically, when I hire somebody as a developer, I ask the person, are you an emotion/beauty person or are you a number crunching / data person? So I ask a set of questions. Do you like colors? Do you like to see things? Do you like emotion and so on? So if someone likes the aesthetics and emotion, they're a front-end developer. They like the way it's presented. They like the emotions, the experience which the user is going through. It's like you're very good at serving the meal to a customer. You're the front-end person in the restaurant, right? But you're good at the actual chopping and cooking and delivering the meal. You're a back-end person. So the numbers / data people, the logic people, the intelligence people usually sit in the back end. Well, the front end people are about how you create that best damn experience for the customer. So that's my remark number 1 in this workshop. So now let's understand the data flows between the front end and the back end. So now if you're a customer, on the machine, you make a request. You say, hey, I want this. So when you make a request, I'm the front end machine. So let's say I'm a waiter. You told me I want this on the front end. Now I need something from the factory. So now I go to the factory and I ask, hey, I want this. Now, let me ask this question. If somebody comes to the factory and says, hey, the customer wants this fish fry, would the factory directly entertain this request or would the factory have to do something? Check if the person is.
Could you once repeat the question?
Now, let's say, okay, let me use the storeroom analogy here. So, factory and the store analogy here. Let's say you're a store which is selling mobile phones and a customer has come and said, give me this Nokia phone. The store doesn't have the Nokia phone. So the store sends someone. That guy goes to the factory and says, give me this Nokia phone. Now you're the factory. Do you directly go give him the Nokia phone? You're a huge factory of 1,000 stores all over the country and all over the city. What will you do first?
I think there will be a lot of hierarchy of talking first.
Check the ID card first, right?
Yeah.
You verify if that person is a valid person or not. Now, you verify if that person is allowed to, make that request. Now, let's say the person is allowed to make the request, but the person has not got all the details. Do you directly connect this person to the manager in the factory? Would your receptionist has verified the ID card, but would your receptionist allow this person directly? Or would the receptionist check if the person has everything with him? Let's say the person has Nokia phone, but the person doesn't have model number. Or the person has model number and Nokia, but the person doesn't have preferred color. So would the receptionist allow this person to talk to the purchase manager? It's a waste of that guy's time. No? Again, he has to say, go get me the color. He has to go get the color. And then, so the receptionist already verifies that the person has all the key details or not. Okay. By the way, this receptionist is called a middleware. And the courier who's coming from the front end to back end is called an API. So the API goes with the request. The request hits a middleware. Now, let us say you serve multiple mobiles, you serve tablets, you serve different things. Would every courier go and ask the same receptionist? We learn from the famous SBI, right? Counter number 11 pe jao, counter number 5 pe jao. You have different counters. In SBI, you're always going counters, right? You never get your things sorted. Yeah. So, yeah, this joking. So you have different counters. So different requests are for different counters so that your traffic is distributed equally. Or what will happen if entire traffic hits one counter, one receptionist is completely occupied and the other receptionist is like idle? Or this receptionist is trained to handle these requests, while the other this receptionist is trained to handle all mobile phone requests, and the other receptionist is trained to handle all the tablet requests, and the other receptionist is trained to handle all the, say, PC requests. I hope you're getting what I'm saying, right? So you have different ports. So different port is meant for different kind of requests. So there's the front end, there's the API. So the front end makes the request. I mean, the person clicks a button and says, I want this. So when the user clicks a button, the front end makes a network call. And that network call then hits a port. With the network call, they hit a port. So the port is a receptionist. So when it hits a port, the port then takes the request. The request is basically at this port and a certain kind of request. I want this data, right? So then the port runs a middleware. Once the middleware checks that, hey, this is a valid request and these guys have all the information, then the controller is called. The controller is basically the program on the server which caters to that request. So the controller takes the request data, all the data in the request, and the controller performs the operation. Let's say you're a Flipkart and you want the user has searched for all laptops. So the API goes, the front end makes a network call. So the network call is show me all laptops with a budget of less than, say, 50,000 rupees. Then the middleware checks if all the information is sent by front end or not. If the middleware says, hey, front end has given me all the information, then the controller is called. The controller is told, hey, get me all the laptops under 50,000. So then the controller goes and uses the driver of the database. So the database is where you store all the information. So there's something called a driver. Using the driver, you talk to a database. So the server talks to the database. The controller talks to the database, gets all the information, and gives it to the front end. And what it gives to the front end is called a response. The front end gives a request and gets back a response. And in between, there's a port where you're supposed to, make this request. And there's a middleware which comes in. So when and once the middleware approves, that's when the controller is called, right? So when you set up the APIs, you tell the port, you tell the middlewares which have to come in, and you tell what kind of. So there are various kinds of methods in APIs. There are 4 to 5 methods. So 4 fundamental methods are called CRUD: create, read, update, delete. So create API is like, I'll create a new record in the database. Let's say you're Flipkart and you have a software through which your team can list new items, or you're a school, you want to list new students on your platform. There's a create function. That is, you say, okay, Nayan is a new student, is of grade 5 and is studying social studies. You enter all this information, a new record is created in the database. That's a create API. That is, your front end goes and says, please create this new file. Add this new file in the library. Read is like, go get me this information from the library. Update is like, please go and change this name. His name is not Nayan, his name is, say Rajat. That's update API. Delete is like, go delete this information from the library. So these are 4 kinds of requests, 4 fundamental kinds of requests. They're called CRUD. So whenever you hire a new backend developer, so the first thing the backend developer is taught is how to do CRUD. You must have heard the word CRUD. So if the backend developer is able to do CRUD, it means the backend developer is able to interact with the database and do certain things with the database. That's one of the most fundamental things. Now, one reason why we use databases and not Excel sheets is because databases are already optimized for a lot of things you do. You want to find some information, you need not worry about the most efficient way to find the information. You need not worry about the most efficient way to find the information. The databases are already optimized for that. So all you do is you use the existing methods of the database. So your backend developer learns how to use the drivers and the existing methods of the database. So you learn how to do the CRUD operations using your database. So that changes from database to database, but fundamentally it's the same. The concepts are the same, but different databases give you different possibilities. And again, based on the nature of data, there are various kinds of databases available. For example, MongoDB is one of the most popular databases. That's a document database. In a document database, your data is not structured. Your structure of data can change from time to time. So you might initially be storing name Mayank, city Surat, interest, startups, only these three things. Later on, you can add a new field, say mother tongue. But if you're using a SQL database like SQL, you've got to define the structure of database beforehand. So all your input entries go as per the structure. So if you do not know how your structure could be, you use a document database that's called a non-SQL database. But if you know your structure beforehand, for example, you're entering bank data or some school database and you know what information you're storing, you're better off using SQL databases. And I'm guessing with SQL databases, you should be able to do a lot of operations a lot more efficiently compared to a document database. But in startups, typically we love document databases because in startups and Clarity don't go together in a sentence, right? So document databases suit us better because the product could change with time. Now, there are various other kinds of databases. So based on the nature of your data and the nature of your use case, you use various databases. For example, you're using a lot of network algorithms. You're doing a lot of things on the network. So sometimes graph algorithms could be, graph databases could be better and so on. But most cases, you're using a SQL database or a document database like MongoDB, right? So this is how your entire universe works. So the user clicks a button or the user does something, an API gets called. So the request goes, hits a port. Once it hits a port, then the middleware runs, the middleware checks. The middleware checks, is this person authenticated to do this or not, right? For example, you have an API which is a delete API. So for every delete API, you might write a default middleware and say for every delete API, I will use this middleware. This middleware checks if this user is an admin or not. Because I do not want somebody who's not an admin to be able to delete my records, right? So, for example, in Deep Thought, we have some, we wrote our own database methods. We don't allow our interns to use the MongoDB methods. We wrote our own methods. So if an intern uses our delete method, it does not delete the record. It moves the record to archive, and a method which is in archive is not accessible to API calls. So by mistake, if an intern deletes the data doesn't go away, it's in our archive. You understand why we wrote our own database methods, right? So this is how this is how we designed our mechanisms work. And I don't code. I came up with this mechanism because we wanted to be intern friendly, and yet at the same time we didn't want to blow up our stuff. So that's how we said, okay, this is how we restrict our privileges to interns, and yet we give interns the opportunity to do a lot of things. So I hope let me draw it so that you can visualize all of what I said. So here's your front end. Now, when your front end makes a request, it hits a port. Once it hits a port, on the port, they check what kind of API it is. Is it a create, read, update, delete, and so on. In the technical language, there are other things called get, put, post, patch, and so on. Ignore that. They're basically ways of implementing CRUD APIs. So depending on what kind of API it is and which port, the middleware could be called. And once the middleware approves, then the controller gets called. The controller is basically a function or a logic which sits on your server. Now, the controller might interact with some more controllers, or it might interact with a database where it fetches the information from the database, processes, and that API goes and gives it back to the front end. So basically, it's an interaction between the front end and the back end, right? And the API does it. Now, to give you a little more insight, there are various ways of ensuring the connection between front end and back end. One way is called an API. Now, an API is something which is triggered by the front end. Only when the front end wants to talk, it can talk to the back end. The back end cannot talk to the front end whenever it wants if you are using an API method. That respects the privacy of your user, right? Paytm cannot talk to you whenever it wants. You talk to Paytm when you want. but Paytm may want to talk to you. So then what do? They push mobile notifications or web app, Chrome notifications, and so on. But otherwise, if you use the API method, you can talk only when the user calls you. But let's say you're creating something like WhatsApp, and Hemant sends a message and Devmita responds. Mayank is watching a cricket match in the other room and is not checking out the WhatsApp. But you want Mayank's application to refresh. But Mayank has done nothing. Mayank has not called the server. So me as the server, I want the privilege to be able to communicate with Mayank's PC constantly. So then we don't use an API, we use something called a socket. So an API is like one-time thing, right? A courier comes, takes information and goes off. But a socket is like a tunnel. It's constantly communicating between front end and back end. But the socket expires whenever the session expires. You have something called Confluence Kafka, where the thing is constantly there, and you can do a lot of things live. But again, whether you're using Kafka or whether you're using socket, you're going to be eroding a lot of bandwidth. You don't want to be doing it unless you want it to be updating live. Now, one mistake a lot of people make is they say that sockets are needed for when it is live, and APIs are needed when it's not live. Not true. If it's just one user who has to communicate with the server, you don't need socket. You can make network calls, right? The user wants a refresh, you can make a network call. But if there are multiple users and you want one user's action to automatically update the other user, then you might need a socket, because Jhansi made a request and I automatically want to update Hemant, but Hemant may be sleeping. I can't talk to Hemant. But if I have a socket, I can talk to Hemant's PC. So if I want my backend to be able to communicate to the client, setting up a socket can be nice, because even if my client is not triggering anything, I can use the socket. Okay, I'll not go into too much of details. I will probably stop here. But I hope I made a compelling case for you that even if you're not a coder, I think you can understand what's going on there. And now, maybe I'll just introduce one more concept. So now, if you are doing a project, typically what you require is, and by the way, on the front end, there are more things. On the front end, we write some logic on the front end, right? Certain things. For example, you want to convert currency, or you want to convert the time to different time zones. You may not want to do it on the back end. It'll be taking too much of time. You may do it on the front end itself. It's like, let's say you want to customize the coffee for a person with sugar. You may want to do it on the front end. You may want the waiter to do it. You don't want to go all the way to the kitchen, get the sugar added and rush to the customer, right? So certain logic, you run it on the front end, and there's certain dynamic functionality, right? The person clicks on a submit button, you open a drop down Moodle, the person enters some details, you take the details. So all those functionalities are done on the front end. So a large part of front end is dynamic events. Event handling is on front end. So one amazing thing with event handling is event listeners, right? So where you event listeners tell you what the user is telling. So basically stalking, right? You sort of observe the user very carefully. So through that you can collect intelligent data. Where is the user? Where is the mouse hovering? So through that you're telling your application that if the user is spending most time on the biscuit section, I will show a lot of biscuits to the user. So you're trying to understand what the user is doing. Is the user clicking a button? Is the user hovering the mouse over something? So certain actions you can understand through the event listeners. So you want to understand the behavior of the user. You'd want your front end to be excellent. You want your front end to be tapping into those. You want your front end to set up a lot of event listeners, right? And on the back end, you may want to store that data if you need it beyond the session. But if you need it only for the session, there's no point of you storing it on the back end. You listen to the data, and based on the data, maybe you change something on the front end. So doing the event listeners is important. Now, when it comes to project management, so the way I do project management, I'm not explaining the entire project management, but if you're interested, you could do one of my sessions on project management where I teach 4 steps of executing a digital product. But I'll only focus on one aspect today. So on the front end, you would want wireframes where you know what are the various screens, how they look like, and what happens when you click on each screen and so on. And you'd want to understand the dynamic things which happen on the front end, right? I click this button, this happens, and so on. So once you're clear there, the challenge when you build an application usually is, what all databases do I need? What all kind of data am I storing on the back end? And related data, I store it in one database. If they're not related, I'm better off storing in different databases so that I don't have to. I mean, it's like you're storing documents, right? You don't want to store everything in the same file. If the irrelevant data, I store it in 2 different files and I retrieve them, right? So you define what all databases you want. Now, the reason why you store irrelevant data in different databases is you modify this. You don't want to modify the database for everything, right? So let's say you have one database for the students' basic information, and you have a different database for the students' science subject performance. You have a different database for the students' social studies performance. Because the fundamental database, you don't want to modify it too often, right? Like the students' basic details like phone number and all. You want to do it once and you don't want to give access to the database to everybody. So by segregating the data in different sections, you are basically making sure the data flows are smoothly managed and your security is also better handled, right? Now that is one part. You understand what your databases are. Then you understand your data flows. Which screen on the front end is going to talk to which database. And there you understand where you need a controller and where you need an API. If the change is going to happen purely on the back end and the front end doesn't have to be involved. Okay, here again, I would like to introduce you to one concept. You may want to just doodle so you don't forget. The concept is there is certain computation which can be done on the back end and certain computation which can be done on the front end. Now, if you are if you're loading the profile page of someone, or you're loading the ticket of someone, somebody booked a ticket and you're loading the ticket. The data does not change from session to session. No, the data is the same. It's just personalized for each person. So what do? You go to the backend, you fetch the data, you generate the HTML on the backend itself, and you show it on the front end. Why do you generate the HTML on the backend itself? Because you don't want to do the unnecessary computation in the front end. Because on the front end, your computation is expensive. The front end could run on a mobile phone, right? The mobile phone could be a very basic Android phone. It may not have so much of power. So if you can do it on the back end, you're better off doing it on the back end, right? So if your data is not going to change in between the session, I might use some templating languages where I, create the HTML on the back end itself and I show it, and I send the HTML to the front end. So here I don't even use an API because the front end need not talk to the request need not come to the back end. The backend itself generates the HTML and sends it to the front end. So that's where we use only a controller. We don't need APIs. Life is a little easier when it's just a controller and not too many APIs. You don't have to worry about all that, right? So we understand whether it's a controller or an API, which talks between the wireframe and the database. And every database you define, you have something called a data model. What's a data model? Data model is basically the template of the database. What all fields am I going to store? Right? And every API you design, for every database, you have a schema. That's called a schema. Schema is the template of your database. Schema is the template of your database. Now, data model is what you have for the API. Data model is basically the template of the data flow. Let's say on Flipkart, you're getting the information of some item. You're not going to take all the information. You're probably only going to take the image of the item, the price of the item, and the name of the item. You may have some other information like which shop is selling and all, and maybe you're not going to save it on the front end. So then you're not taking all the information from the database. You're only taking the required fields. So the required fields of the database for the API is called a data model. So when you do your backend, when you're creating an API, you write down the data models. When you create a database, you write down your schema. Your schema is the template of what all things you need in your database, right? And when you create your API is a data flow that is from the factory to the shop. Factory to the shop, the information is coming in. So you write down these are things which I need. So now when somebody starts coding, they first write down the wireframes. And whatever dynamic functionalities you need in the front end. Then you understand from a back-end perspective, how many databases do I need? What all communication flows are happening between the database and the wireframe? How many APIs do I need? How many controllers do I need? Once you know what APIs you need, what controllers you need, and once you can write down your data models and schemas, backend is a piece of cake. The challenge usually is in designing that flow. And on another day, I'm happy to take a hands-on workshop where I take one app example and show it to you how to do this entire project management when I do the project management workshop. And there you'll understand that even a non-tech person can do this. So defining what databases do I have, what are the data flows, and what all data is going to move. And you know what? If this entire process flow is defined, even an intern backend developer can do your backend. People say backend is complex. I need a developer with 2 years experience, 3 years experience, 10 years experience. I see a lot of startup founders saying, no, this can't be done by an intern. Like, I come to Deep Thought, I'll show you. Right? Our interns have been releasing amazing products, but the heavy lifting has to be done by the person who understands the business really well. So as Chandra said right at the beginning, that I want to teach them business and I want to learn tech from them. This is where your business acumen comes into play to define that entire architecture of which data goes from where to where. How do you want to organize it? If you can organize it, I mean, at a later stage, probably, you'll need a good person to organize it in a neat way. Otherwise, your application will run too slow. But at least in the initial stages, I think you can sit with the folks and you can design, I need 5 databases and this is how the communication flow happens and so on. But if you're a logically sound person with experience, even you will be able to design the flow and do it. And once the flows are designed, trust me, it's a piece of cake for a backend developer. And the beauty of backend development is the number of lines of code is very less compared to front end. Front end is like insane amount of lines of code, right? So yeah, this is pretty much how things work. And I hope I met my 3 objectives. My objective number 1 is you won't be scared of the jargon which people throw at you. Even though I've not covered all the jargon, I hope I've convinced you that the jargon can be understood with a simpler language. And number 2 is I said you'll understand the entire project, right? On the front end, it's just the wireframes and the logic of what has to happen there. On the back end, middlewares usually are default. Okay, you have standard middlewares, which you can use. So on the back end, and ports also, defining the ports and middlewares is a basic job. But the main thing is to understand what kind of APIs you have. Because once you understand what API, they write the controller and they define the middleware and the port for it. So backend largely is about getting the data flows, right? Which database to which wireframe communication is going. Then implementing the logic is not too tough. So, and my third point was to say that you with interns, you'll be able to go ahead and start executing. I hope this met the objectives, but yeah, I'm happy to take some questions.
Hello.
Yeah, hi Vishwesh.
Hi. Just would like to understand. I do have 2 questions, right? So people do say that, right? To work on the tech side and all those things, right? You need certain kind of a mindset. So what is that? I mean, you need certain kind of a mindset, thought process, right? To understand, build the good tech, brilliant tech product. So what exactly that?
So I think Vishweshwar, I would say one of the most important things which is important, most important things for a tech company is a sense of elegance in the logic. Now, why elegance in the logic is important is because when you do things in an elegant way, even when things scale up, they happen in an efficient way. And if your logic is elegant, your tech becomes robust. Even if conditions change, the same tech works. Your code becomes reusable. So having an appreciation of elegance of logic or elegance of structures, I think is important. that comes when you work on more and more tech, right? When you understand how you can make your tech cleaner. That appreciation of what is quality code, I think, is important. And what is quality code? I think that comes when you're able to structure that code really, really well in a very elegant way. Because there are so many ways of solving the same problem, but you want to structure that solution in a very elegant way. Because when you structure it, it's more robust. When circumstances change, it might still be intact. And even when you do things at a larger scale, this might still work, right? So I think appreciation of that elegance is extremely important. Then another aspect is how you write a good commenting structure. What is your thought process, right? When you're writing a code, what is your thought process? Why you're doing it? Writing some comments on the right side so that another developer who's reading your code is able to understand what you're doing is important. Amateurs, especially when you outsource your technology, most of these companies which outsource technology, their commenting structure is poor, their code quality is poor, and founders suffer when they have to take over that code later on, right? That's a huge difference between product companies and service companies. Developers of service companies usually suck big time. So, because they don't understand these code standards which we place in product companies, right? These TCS guys and all, that's where, I mean, they may have better commenting structure, definitely, because they're in large corporates, but I think they're not trained to think in a product perspective when a product scales up. How do you do it? So, yeah, so that's my second point, that commenting structure. My first point was the elegance of the logic, right? The various ways of implementing it. You want your logic to be very elegant so that it's reusable and it scales up. And my third point is that on the front end, you think of the user experience. So as you work with more and more products, you understand that there are some validations you do on the front end before you go to the back end. There are certain processes you take care of on the front end, right? And on the back end, again, you want to understand whether you're grabbing all the data, whether you're thinking of all the scenarios and so on. So I think if you're a logically sound person, you'll be able to do well in tech. I hope I've answered your question. 4 points I have mentioned.
Hi, yes. Yes.
Yeah, Pratik, please go ahead.
So yeah, hi Tarun. Thank you for the awesome session. I loved it. I am like upskilling as a tech guy. I have like run a small agency, namely Comjet, beforehand. So like as you said, for the like the having a robust tech structure and having like a good sense of commenting code, good sense of writing like the perfect or the good code, right? So it's a little related to tech. That like how what is the like the process of like being a good developer, as in the sense of writing good code or writing good comments? Does it is it only based on experience, or we can like think of this structure that there is a structure for this that we can follow on for?
So, Pratik, I think we did a series of workshops for our developers. I'm happy to share the recordings. I did 3 workshops on reading code like a story. If you can practice how to read code like a story, I think that can help you write good comments, and that can help you think of things in a very elegant manner. And the second point I would say is, if you can practice a lot of data structures and algorithms, if you can read more about data structures and algorithms, that doesn't have anything to do with coding. That's more like Akbar Birbal stories, riddles and puzzles, right? If you can master algorithms and data structures and do a little bit of algorithms and data. I mean, a lot of people insist on computational programming, competitive programming, which is they give you a lot of problems and you solve the problems and all. That's definitely nice, but I would say that's not mandatory as long as you have good understanding of algorithms and data structures. In fact, if you can code and if you're very good at algorithms and data structures, that's exactly when you succeed in competitive programming. Because in competitive programming, what they do is they give you excellent logical puzzles and ask you to solve it. But to be honest, when I hire interns or train interns, I don't focus on competitive programming. A lot of companies focus on competitive programming, and that's exactly why I make great hires and they're not. Because when you insist on competitive programming, you get very tiny segment of the talent pool. Because unfortunately, our Indian education system sucks. So as a result, a lot of people are not very good with logical thinking and they struggle with competitive programming. But when you hire people and they have a good understanding of your business, over a period of time, they pick up that logical thinking as they do more and more coding. You can slowly start teaching them, competitive programming, algorithms, and data structures. But for me, when I hire a developer for a startup, bhai utna optimized code nahi laga rahe hain. Initially, we're just making an application which works. So you don't need somebody with, who can optimize it all. So as long as the person can understand your business logic and execute things, and if the person can come up with creative ideas of what's needed in your product, that person is a fantastic developer. But over a period of time, once the person works with you, slowly you expose that person to, algorithms, data structures, competitive programming, and the person can pick up. You might ask, algorithms and data structures are a part of BTech computer science syllabus. Why do people suck at it? I would say education system sucks at large, and that's exactly why people don't know it. And algorithms and data structures need to be taught well, and they need to be taught in a philosophical manner. What is philosophical manner? I hope now you get it. So pedagogy matters, and unfortunately in colleges the pedagogy is not proper. By the way, I come from Indian Institute of Science Education and Research, which was set up by Indian government to bring PhD level research to undergrad level. I did my undergrad there, and my master's thesis I did it with IMSC Chennai, Institute for Mathematical Sciences Chennai. I worked with Professor R. Ramanujan, who happens to be one of the world's best computer scientists at IMSC Chennai. So yeah, I was taught by some of the best people, and that's where I learned how to understand computer science this way. Unfortunately, it's not taught to people this way, and that's exactly why most interns have challenges. So that's why I believe algorithms, data structures, competitive programming can come at a later stage, but these things are more fundamental to me. But if you ask me, where does elegance come from? I would say first, if you can learn to read code like a story, if you can learn to appreciate code like a story, I think it can come from there. Did I answer the question?
Yeah, you answered the question.
Yeah. So
I can relate to this because
I'm saying if you're
yeah, sure, I will
interested in code like a
ping
story, you can ping me like WhatsApp, and from my team, I'll take the recordings and I'll send that recordings to you.
Sure, sir.
Private Google Drive. I'm happy to share that with you.
All right. So Tarun, thank you very much for the session. It's really informative. Thank you very much. And it would be great. It's just my feedback. It would be great, like if you can make it available. This is a simple process, like whatever you explained on the whiteboard. It's like very understandable even for the school kids. If you can just do that, even with the other different technologies. Let's say, for example, if I want to build a fashion e-commerce platform, like how we can build it, what kind of technology stack we use, which thing does what. So in a simple like this way, it will be like much faster that we can execute our businesses. This is so one example, like different people have different needs. Somebody might want to build some delivery platform, somebody might want to build some product platform, but it will be like super useful so that we don't get like confused and first of all like intimidated by these tech jargon a lot.
So Chandra, I have a 2.5 hour workshop where I take a healthcare app as a case study, and I take the participants through a complete project management workshop. I'm happy to share the 2.5 hour recording with you. Or in this Feynman technique kind of an approach, which is I use simpler examples to convey without jargon. So I've already done this while training some of my interns. So as you know, our core business and deep thought is we train interns of tech companies and get them to meet the productivity of developers with 2 to 3 years experience. So we have done lots of workshops internally. I'm happy to share some of the recordings. This one, a 2.5 hour recording, I'll find it and share it with you. That takes you through the complete due diligence process of how you plan your project.
Okay.
And send it for execution for the front end and the back end guys. I'll share that recording with you.
Perfect. Thank you.
Hey, also, I would like to take that. Love to see that recording that you are sharing, right? So if you can share it
with
on a
everyone.
WhatsApp group or something.
Sure. I, on all the WhatsApp groups, I'll make a nice list and share it with all of you.
And Tarun, if you don't mind, can I ask you a very simple question?
Yeah.
So when we are hiring, we specialize, okay, we require in Java, we require in this or that. So, I mean, it appears that once somebody understands the basic logic, it is very easy to switch from one to other. So
Yes.
what is your comment on that?
So
do we really require such kind of super specification, or still we can hire someone who has got a big, good reasoning and give him some time to switch over.
Okay, so if you look at very good actors, right, or very good singers, they switch between languages, right? Someone like SP Balasubramaniam sang in so many languages. Once they pick up the basics of singing, even if they don't understand that language or what that word is about, they manage to sing well, right? So in the same way, if you see, because the fundamental thing when you build a software is you have a logic and you implement the logic using a language, right? You implement the logic using a language. Let's say you're saying you're calling the database and you're telling the database, show me all the records with the name Nayan in it. Show me all the users with the name Nayan in it. How many users do I have? You can do it with Django, you can do it with Python, you can do it with Node.js, you can do it with PHP. Now, different languages give you different kind of benefits, right? But the fundamental things can be done in all the languages. Now, if you are doing an AI ML intensive project, Python seems to have a lot of libraries available. So a few people go with Python. Now, you want to control the user experience really, really well. JavaScript is nice if you want to have a very good user experience, and that seems to be a very popular stack. But you're building an application which is going to operate at a huge scale. You're usually not going to use Node.js because Node.js optimizations are not great. So that way you change the language based on the requirements of your project. But the overview of all the languages is pretty much the same. So you have a good developer with you, and the developer understands one front end in one language or back end in one language. To switch to another language should not take more than 1 week for a good developer. Because the logic is the same. The way you write, the syntax changes. It's just like a translation. But yes, why 1 week? Because in that 1 week, the person goes and reads the Wikipedia articles and all of that. What is the history of this language? Why was this language made? What are the specialities of this language? For example, if you go to, we had one workshop on React.js. If you watch that workshop on React.js, I was basically figuring out React.js along with my interns. I don't know React.js, I was figuring it out. We went through the website of React.js, we went through the documentation of React.js, and we understood why they built React.js and how React.js compares with traditional JavaScript. So in that workshop, what I did is we wrote a code in JavaScript and we wrote the code in React.js. We compared both and saw what was the advantage of React.js. I did it in a true research-based manner, like how they do it in MSc. But to answer your question, Mr. Devashish, it doesn't matter at all. I mean, once you know one language really well for backend, to pick up other languages doesn't take much time. Most of the time usually goes into understanding how you can exploit that language. What are the specialities that language is going to provide you, right? So how you can leverage that language is what you would spend time on. Because see, good coders, right? Good coders don't remember the syntax. They copy paste from Stack Overflow.
Great. Okay.
Good coders always copy paste from Stack Overflow. The point is to get the logic. You pay the coder for the logic, not for the syntax. Syntax, you get it on Stack Overflow. I mean, you talk to any good coder, they'll tell you they copy paste code from Stack Overflow. They don't have the time to go and write everything or remember everything. They copy paste the code. The challenge is to know what to copy paste from where. Getting the logic is the most fundamental thing.
Yes.
Okay. On this note, I will conclude the workshop, and I hope you all had a great experience, and I hope this helps you in implementing your projects.
Fantastic. Thanks, everyone. Thank you, Tarun.
Thank you.
Thank you, Arun. Please send the recordings.